Lesson 4.1 is inequalities and their graphs for algebra. 4.1, so title your paper, and we have one key term in here, and it says a solution of an inequality is any number that makes the inequality true. For example, the solutions of the inequality x is less than 3 are all numbers that are less than 3. So, here's what they're going to have you do. Now, this is just a quick review. Is each number a solution of x is greater than or equal to negative 4.1? So, is negative 5 greater than or equal to negative 4.1? No, because if you look at the number line, negative 5 is less than negative 4.1. So this is no. Number 2, is negative 4.1 greater than or equal to negative 4.1? And that's yes. Number 3, is 8 greater than? Yes. And is 0 greater than? And that is also a yes. Next, is each number a solution of 6x minus 3 is greater than 10? So in these type of problems, first what you have to do is solve this. So you're going to add 3 to both sides, and you get 6x is greater than 13, and then you divide by 6. So x is greater than 13 over 6, and you can write it as 13 over 6. Or if you want to write it as a mixed number, you can do 2 and 1/6. So is 1 greater than 2 and 1/6? Is 1 greater than 2 and 1/6? This is a no. Is 2 greater than 2 and 1/6? And that is also a no. Is 3 greater than 2 and 1/6? And that's a yes. And 4 is also greater than. So just a reminder, when you're doing the graphs, remember that an open dot goes with an inequality that is greater than or less than. Open dot. If it's greater than or equal to, less than or equal to, it's a closed dot. So make sure you jot that down in your notes. Just a refresher. Graph each inequality. So graph these 3, and then we'll correct it. Okay, so I draw my graph. Remember, you don't have to write a big, huge graph. You just need to put your number right in the middle, and then do one number on either side. This is going to be an open circle at 1, and it's everything less than. This is less than. Remember, if you need a little help, at the top of my paper, I used to write that, because that's less than, and then I knew that this was greater than. So that might help. N is greater than or equal to negative 3. So that's a filled in circle, and it's everything greater than negative 3. And then lastly, now, when I do this, I rewrite it so it looks like this. I put my P out front because the variable needs to go first. And then I switch my sign because I look and I see, okay, well, it's pointed towards P. So this has to be pointed towards P. And then I have 2. So I have an open circle at 2, and it's everything less than. Write an inequality for each graph. So now I have to go backwards. And you can pick any letter, remember. So I'm going to do X is greater than or equal to 2, because it's going greater than, remember that. This gets pointed in the direction that your arrow goes. And then this is X is less than, just less than, 0. Okay, define a variable and write an inequality for each situation. Let S equal the legal speed. So then the sign indicates that S is less than or equal to 65. So that's what that means, less than or equal to. Let P equal the pay per hour. So the sign indicates that your pay could be greater than or equal to $6.15 an hour. So try this. In part A of example 5, can the speed be all real numbers less than or equal to 65? Explain. So can the speed be all real numbers? So can you go 27.3? Yes, you can. It can be. It can be all real numbers. However, the speedometer and all the reading meters round it to the whole numbers. But yes, it can be all real numbers. Gosh, sorry. In part B of example 5, are all real numbers greater than or equal to $6.15? Reasonable solutions of the inequality. Are all real numbers greater than or equal to $6.15? Reasonable solutions. So what do you think? Could it be $7.25? Could it be $7.35? Could you get paid $8.42? And yes, because it doesn't matter what, like, you don't have a say. So you could get paid whatever they decide, and it goes to the hundredths place. All right, that's it for your notes.